Welcome back to my YouTube channel. Listen this lyric.
చిన్న 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 నవ్వులే వెతకడమే బ్రతుకంటే కొన్ని అందులోన పంచవ మిగిలుంటే.
The meaning of this lyric is searching for little tiny smiles. All around you is life. Share me those if you are left over with them. Chalo guys, let's start our today's topic 3 in machine learning, that is data representation. Data representation is a fundamental concept in machine learning. It encompasses how raw data is transformed into formats that algorithms can process efficiently. The quality and structure of these representations significantly influence the performance of ML models. In ML, data is the necessary thing. Data is the main thing. And the fundamental concept of machine learning is data representation. Key types of data representation in machine learning. First one, tabular system, which is attribute value type. This is the most common format, which the data is organized into rows and columns. Each row represents an instance, that is a customer, and each column represents a feature. Feature in the sense age, income, date, color, etc. This structure is prevalent in structured data sets like spreadsheets and databases. Presented a small diagram which is for tabular data, and second one is one hot encoding. One hot encoding, it transforms each category into a binary vector. We know the binary value 0 1's format. For example, a color feature which values colors like red, green, blue would be represented as, for red 100, for green 010, blue 001. In this method, the model ensures doesn't infer any ordinal relationship between categories. Okay, let's talk about ordinal data and nominal data. Data which involves categories that have a natural order or ranking. Example is if a survey conducted by someone. For example, the satisfaction ratings from a customers will be very dissatisfied to very satisfied, which means order: satisfied, not dissatisfied, very satisfied, like very satisfied, satisfied, dissatisfied. This is the order hierarchy. Importance of order ranking, which is involves in the ordinal data. And for nominal data means it does not represent the categories, which means it is without any inherent order or ranking. Examples include gender, race, types of animals, example mammal, reptile. These are not a inherent order. This is the nominal data. Ordinal data, ordinal order. Nominal, not in order. Just remember it. That's it. Next, third one is embeddings. Embeddings are dense vector representation of data that is particularly useful for the high dimensional or categorical data. The words are mapped into the continuous vector space, and it has a semantic relationships. For example, king queen might be represented as a vectors that are close in this space, like king and queen are in the same kingdom, right? King queen, there is a relation between two. Like embedding means relationship between the other, one to the other. This is called a semantic relationships. Next, numerical and ordinal encoding. Numerical data, we know that age, salary is directly used as the input features. These are numerical data. And ordinal data like education level, high school, bachelor's, master's. In CV, we have seen that education level would be smaller to higher or higher to smaller. Ordinal data, which is higher to the smaller, like master's, bachelor's, high school, right? Can be embedded using integers that reflect their inherent order through advanced representation technique. Representation learning. This approach involves learning the best way to represent data from the data itself. For example, conventional neural network can learn hierarchical representations of images starting from edges to complex objects. Hierarchy means what? Higher to the lower means hierarchy, right? Next, dimensionality reduction. Techniques like principal component analysis, PCA, and T distributors or stochastic neighbor embedding, TSNE, are used to reduce the number of features while preserving the data structure. Particularly useful for visualizing high dimensional data or improving model efficiency. We have three types of data in machine learning. First one is structured data, second one is unstructured data, third one is semi-structured data. Structured data means it is a organized data, like organized in rows and columns, suitable for traditional ML algorithms. Second one is unstructured data, includes text, images, and audio, requiring specialized models like CNNs or recurrent neural networks. Third one is semi-structured data, contains tags or markers to separate data segments such as XML or JSON files. This is all about the structured and unstructured data types. And in the below diagram, I have represented both structured data and unstructured data. First one is unstructured data. In a flower, there is unstructured more like petal, sepal. For tablet data models, input layer, pre-processing layer, embedding layer, hidden layers, output layer. Input layer, it accepts raw tablet data which may include both numerical and categorical features. Pre-processing layer, it handles data normalization for numerical features and embedding for categorical features such as one-hot encoding. Third one is embedding layer. It transforms categorical variables into dense vector representations, capturing semantic relationships between categories. Fourth one, hidden layers, consists of fully connected layers, also known as dense layers, that learn complex patterns in the data. Fifth one, output layer, produces the final prediction, which could be classification, label, or a continuous value depending on the task. We know that machine learning accepts raw data and gives the output prediction, final prediction. And below I have represented a diagram for machine learning. First input image, next feature extraction, classification, output, person or not. Input is image is person and the feature has been taken. Later it classified and gave the prediction person or not. This is all about our today's concept. Thanks for watching. Like, share, subscribe for more videos.